Imagine a world where the sky is neither blue nor black. A world where space itself is filled with the scorching breath of a star, and the planet's atmosphere does not stay in place, but drifts away into space like smoke from a colossal fire. A world where the planet does not simply orbit its sun. It slowly dissolves in its light, leaving behind and ahead of it two ghostly streams of gas, like a comet, but the size of an entire world. And this world truly exists. It lies hundreds of light years away from Earth. And only recently, its secret was revealed by the most powerful space observer ever built by humanity, the James Webb Space Telescope. When astronomers pointed its mirrors toward a distant star, they expected to see an ordinary hot gas giant. But what they discovered turned out to be far stranger. The planet is literally being torn apart by its own star. Its atmosphere is leaking into space, forming two gigantic tails of helium, one stretching behind the planet like a comet's tail, and another moving in front of it. It was this second tail that made scientists freeze in front of their screens, because according to all the laws of physics, it should not be there. To understand why this discovery is so astonishing, we first need to travel to the planet itself. Its name is WASP-121b. The name sounds almost dry and technical, but behind that designation lies one of the most extreme worlds ever known to humanity. This world orbits its star at a distance that, by cosmic standards, could almost be called suicidal. If we moved this planet into our solar system, it would orbit much closer to its star than Mercury does to our Sun. Much closer. It completes a full orbit around its star in only about 30 hours. Imagine that. For this planet, an entire year lasts just a little longer than a single day on Earth. Such proximity turns the world into a true inferno. The temperature on its day side rises to roughly 3,000 degrees Celsius. That is hotter than the surface of some dwarf stars, hotter than molten lava. So hot that gas molecules cannot even hold together. The atmosphere is literally boiling. The planet belongs to a class known as ultra-hot Jupiters. These are enormous gas giants, comparable in mass to Jupiter, but located catastrophically close to their stars. They are like giant balloons held far too close to a flame. But WASP-121b goes even further. Its orbit is so close to its star that intense radiation constantly bombards the atmosphere. High-energy photons literally knock atoms out of the upper layers of gas. And slowly, day after day, year after year, the planet begins to lose its envelope. This process is known as atmospheric escape. But on cosmic scales, this is not just evaporation. It is a colossal leak of matter. Imagine a gigantic hurricane of helium bursting out of the atmosphere and rushing into space at speeds of tens of kilometers per second. Millions of tons of gas leave the planet every second. If we could see it with our own eyes, the planet would look like a comet of colossal proportions. Astronomers began noticing such tails several years ago using telescopes of previous generations. But the James Webb Space Telescope has a unique ability. It can analyze the light of a star passing through a planet's atmosphere and literally read the chemical composition of the gas. When WASP-121b passes in front of its star, part of the starlight travels through its atmosphere. And in that light remain characteristic signatures of different elements. It's like fingerprints. Each chemical element leaves its own unique spectral pattern. And in this way, astronomers discovered something remarkable: an enormous amount of helium. Helium is the second most abundant element in the universe after hydrogen. It is light, and it easily escapes a planet's gravitational pull if the temperature becomes high enough. And in the case of WASP-121b, that is exactly what is happening. But when scientists began analyzing the data, they saw a structure that directly contradicted existing models. A long tail of helium was streaming out of the planet's atmosphere, stretching far behind it along its orbit. That was expected. The star's gravity and radiation pressure should pull the gas backward, forming something like a cosmic trail. But then a second structure appeared in front of the planet. A vast cloud of helium moving ahead of it along the orbit. It looked as if the planet were both leaving a trail and crashing into its own cloud of gas. Astronomers checked the data again and again. They used different instruments, different signal processing methods, but the result remained the same. WASP-121b really does have two giant tails, one behind it, the other in front. To understand how strange this is, imagine a car speeding down the road, leaving a trail of smoke not only behind it, but also in front of the hood. It contradicts our very intuition of motion. And that is exactly why this discovery has become one of the most intriguing mysteries in modern exoplanet science. But what could possibly create this mysterious leading tail? One hypothesis involves incredibly powerful winds in the planet's atmosphere. Because WASP-121b is tidally locked, always facing its star with the same side, its day side is heated to extreme temperatures, while its night side remains much cooler. This temperature difference creates monstrous atmospheric flows. Wind speeds may reach several kilometers per second. That is faster than the most destructive hurricanes on Earth. Such winds can transport enormous masses of gas around the planet, lifting them high into the atmosphere and throwing them into space. But even that is not enough to fully explain the shape of the second tail. There is another idea. The star's gravity may distort the planet's atmosphere so strongly that it begins stretching toward the star, forming something like a bridge of gas. It is similar to the way water stretches into a stream when you pour it from one container into another. If the planet is close enough, part of its atmosphere may literally flow toward the star. And in that case, a cloud of gas could indeed appear in front of the planet. But even this model does not explain all the observations, which means WASP-121b may be hiding physical processes we still do not fully understand. And this is where the most fascinating part of the story begins. Because this planet is not just a curiosity. It may be a key to understanding the fate of many worlds across the universe. When astronomers first began discovering exoplanets in the 1990s, one thing immediately surprised them. Many of them were exactly like this. Hot Jupiters, enormous gas giants orbiting incredibly close to their stars. At first, this seemed almost impossible. According to existing theories, planets of that size should form far from their stars, where it is cold enough for ice and massive gaseous envelopes to accumulate. But observations told a different story. These giants had somehow migrated inward within their planetary systems. They moved closer and closer to their stars until they reached dangerous orbits. And there, a slow catastrophe begins. The star starts stripping away the planet's atmosphere. First, a thin layer, then more and more. Every million years, the planet becomes slightly lighter, slightly smaller, slightly more exposed. Sometimes this process can completely destroy the gaseous envelope, and what remains is a dense, rocky core. Some astronomers believe this is how so-called hot super-Earths may form former giants stripped of their atmospheres. WASP-121b may be on exactly this path. It is losing its atmosphere right now, before our eyes, at least by cosmic standards. The James Webb Space Telescope allows us to observe this process with unprecedented precision. Its giant mirror, more than 6 meters in diameter, collects the faintest light from distant stars. Its infrared instruments can detect the subtlest changes in spectra. In a way, it turns light into a story, and that story tells us that this planet is slowly dissolving into space. But the most astonishing part is the scale of the tails. According to scientists' estimates, One of them may extend for tens of planetary radii. That means the gaseous trail stretches hundreds of thousands of kilometers. If such a tail existed around Jupiter in our solar system, it could stretch a distance comparable to that between Earth and the Moon. And all of this is simply a stream of escaping helium, invisible yet colossal. The James Webb Space Telescope detects it thanks to the way helium absorbs specific wavelengths of infrared light. Every time the planet passes in front of its star, the tail leaves its imprint in the spectrum, like the shadow of a gigantic ghost. And the more observations astronomers collect, the clearer the picture becomes. WASP-121 is one of the most extreme examples of atmospheric erosion we have ever seen. But this may only be the beginning, because there could be billions of such planets in the universe. Right now, around distant stars, thousands of worlds may be slowly losing their atmospheres. They evaporate. They turn into clouds of gas. They leave behind enormous tails stretching along their orbits, like the traces of cosmic catastrophes. And each of those tails is the story of a planet that was once a complete world. A story of slow destruction, but at the same time, a story of planetary evolution. Because from these processes, diversity of worlds is born. Gas giants become rocky planets. Atmospheres disappear, orbits change, and over time, planetary systems like our own can emerge. Perhaps billions of years ago, similar dramas unfolded even in our own solar system. Planets may have migrated, lost their atmospheres, changed beyond recognition. But today, we have a unique opportunity to observe such processes in real time, even if they occur hundreds of light years away. Every new signal captured by the James Webb Space Telescope opens another page in the chronicle of the cosmos. And sometimes that chronicle turns out to be far stranger than we expected. A planet with two tails, a world that both leaves a trail and crashes into its own gas. The universe reminds us once again that it is far more complex than our models, far more mysterious than our equations. And that is exactly why we keep looking up at the sky, because somewhere out there, among the cold stars and endless distances, lie discoveries capable of changing our understanding of worlds, and perhaps even our understanding of ourselves. Thank you for taking this cosmic journey with us. If you enjoyed touching the mysteries of distant planets, support the video with a like, share your thoughts in the comments about this incredible world, and tell us which discoveries of the James Webb Space Telescope amaze you the most. The universe is vast, and we are only beginning to understand it. Stay with us, and see you next time.